Hello, this is John Kavanagh from DMV Software, and this is a quick introduction to Phast 7. The aim of this tutorial is to make you familiar with the ideas and techniques involved in performing a consequence analysis with Phast, and to give you practice in defining a range of common types of hazardous event. By the time you have finished the tutorial, you should have a firm understanding of the issues involved and be ready to start work on analysis of your own. The tutorial is divided into 3 chapters. In this first chapter, you will open an example analysis provided with the program, explore its main features, and run the calculations and view the results. When you start the program, you do not have to take any specific actions to start a new analysis, as the program always starts with a new blank analysis already open. You can explore the features of the program using the blank workspace, as all the features will be displayed, but this tutorial uses one of the example files installed with the program to give a quick introduction to the terminology and approaches used. So to open the file, from the File drop-down menu, choose the option to Open Example, and then open the Phast 7 example file. The study tree pane on the left-hand side allows you to organise and edit the input data for your consequence analysis. The pane contains a number of tab sections, each of which covers a different type of input data. The Models tab section is used to define the hazardous event or scenario that you want to model, and to run calculations for these events and view the results. This is the main type of input data in the program. There are 4 levels of input data in the Models tab. Level 1 is the workspace and appears at the top of the tree in every tab. If you double click on the icon, a dialog will appear that allows you to set options that will be applied throughout the workspace. The settings will be saved within the workspace file, so you can set different options for different workspaces. The workspace dialog covers settings that affect the behaviour of the program, but does not cover any aspect of the definition of hazardous event. The details of the hazardous event are defined at low levels, with nodes that appear only in the Models tab section of the study tree. You may now close this dialog to explore further features. Level 2 is the study tree level. The study level is the level immediately underneath the workspace node. Each new workspace is created with a study already defined in the Models tab, ready for you to start inserting equipment items under study. The input data for the study covers 2 types of settings. Firstly, the selection of weather conditions and parameters to be used, and secondly, the volumes to be used as default for equipment items under the study. You may now close this icon to view further features. Level 3 is the equipment item level. At the equipment level, you define the process material and operating conditions. There are 3 types of item that you can define. Firstly, a pressure vessel, shown here by the green circle, which is for modelling releases from pressurised containment. Secondly, an atmospheric storage tank, shown here by the blue cylinder, which is used to model releases from unpressurised containment. And finally, the grey box here showing a standalone item for performing detailed modelling of fires, explosions and pool vaporisation, separated from the modelling of a particular release for containment. The example file has a large number of equipment items, most of which are pressurised vessels, but there are also some atmospheric storage tanks and some standalones. The equipment items have been organised into folders under the study in order to make the design of the workspace clearer and easier to work with. For example, there is a tank farm folder and a toxic cases folder. You can have any number of levels in the folder under a study tree and also under an equipment item. In addition to defining the process material and operating conditions, you can also use the input data for the equipment item to set default values to be used for the scenario underneath the equipment item. Level 4, the scenario level, is a hazardous event associated with the equipment item to which it belongs. The types of scenario that you can define under a given equipment item depend on the type of equipment item and can be viewed by opening that equipment item. So for a pressurised vessel, to view the scenarios, go into the right click menu and then insert. And the scenarios available for a pressurised vessel are shown in this illustration. These scenarios model the release of materials through all the stages in its dispersion to a harmless concentration. The model includes discharge calculations to obtain the release rate and state and fire, explosion and toxic calculations to obtain representative effect zones for the dispersing cloud. However, the options for an atmospheric storage tank are slightly different, and they can also be viewed in the right click menu. And you can see here that the spill option is also available, which models a liquid spill in which the entire release mass is assumed to spill onto the ground. The scenarios available for the standalone item, shown again in the insert menu, include 4 types of explosion, 3 types of fire and pool vaporization. The consequence calculations are performed at the scenario level, which is the lowest level in the data structure. We will now move on to the Weathers tab section in the study tree. The Weather tab section of the study tree pane contains a folder named Weather folder with 3 definitions of weather conditions. Each weather icon represents a particular set of weather conditions for use in the modelling of a release and its effects. In the calculations for a given scenario, the program performs a separate run of the consequence calculations for each weather condition, giving a set of results that are specific to that weather. For the example file, the name of each weather gives the wind speed and the atmospheric stability category that are set for it. Each new workspace will normally be created with a number of default weathers predefined in this web folder. You can edit these weathers by opening the dialog. You can also delete them or add new weathers in the right click menu. We will now look at the parameter tab section. In Phast, parameters are background inputs that are applied to all calculations and are not specific to a particular equipment item or scenario. Some of the parameters in the program are used to provide default values for the aspect of equipment item and scenario input that are usually shared between groups of equipment or scenarios. Other parameters deal with advanced modelling assumptions and do not appear in the equipment or scenario input data. The full set of parameters is very large and it has been organised in several groups. The icons for the groups in the example file have a green arrow in the top left hand corner of the icon, as you can see here. The program uses this arrow to show that all the parameters under that icon are used in using the default values that are supplied with the program. If you change the values of any of the parameters, then the green border around the icon will disappear. This allows you to see at a glance which aspects of analysis are using the default values and which are using changed values. We will now move on to the Materials tab section. The program is supplied with a set of system materials that contain full property data for more than 60 materials. However, the Materials tab section does not show icons for all of these materials, but only for materials that have been selected in the input data for various equipment items in the workspace, or for materials that you have added yourself while working in the Materials tab section. So you can define 2 different types of materials. Firstly, a pure component, which is shown by the green test tube. Most of the icons in the Materials tab section in the example folder are pure components. As with a parameters group, a component will have a green arrow at the top left hand corner if all the input fields for the component have values set for the materials in the system materials. You can change the values if you wish. There are also mixtures, which can be defined selecting up to 8 pure components in any mixture. An LPG mixture is defined in this example file. We will now move on to the Map tab section. You use the Map tab section to describe various aspects of the surroundings, such as buildings, the local terrain, and bunds around equipment, and to define images and other graphic data that you want to use as the background for displaying consequence results. The first type of map data is the bund type, which is shown by the brown box, and are used in the program in the modelling of pool spreading and vaporization. You use the bund type folder to define each type of bund or evaporation surface that you want to use in the analysis, and then select the appropriate bund type in the input data for the equipment item or scenario. The second type is terrain type, shown here by the map style image. The terrain type data are used in the modelling of pool vaporization and dispersion. Use the terrain types folder to define each value of surface roughness and terrain type that you want to model, and then select the appropriate terrain type in the input data for the equipment item or scenario. The third map item type is the building type. Building type data are used for modelling concentration build-up for release inside a building and for modelling toxic effect inside buildings in the path of the cloud. You use the building type folder to define each type of building that you want to model for concentration build-up and each type of building that you want to model for indoor toxic effect, and then select the appropriate building type in the input data for the equipment item or scenario. Each new workspace is created with a default bun type, terrain type and building type, and you can edit these or define any number of additional items. Finally, there is the raster image set. The example file has two raster images defined, an OS map and an aerial photograph of an area called South Point, and you can see these images in the GIS input view in the document viewer area to the right of the study tree pane. The equipment items are represented by dots, and you can see that there are many dots distributed over the chemical plant area. The location data for a hazardous event is defined on the equipment item rather than on the study or scenario. The Display Order tab of the legend for the GIS input view controls the order in which the different layers of information are displayed in the view. The equipment item layer is at the top, which means that the dots that represent the equipment item will always be visible. The South Point aerial is second, which means that the South Point OS is obscured. If you swap these two around, the South Point aerial is now obscured by the South Point OS map. The Tools tab of the ribbon bar and the GIS Input Tools tab contain various options for working with the GIS input view. For example, you can use these options to display the name of an equipment item in the GIS view as follows. So firstly, go to the Models tab of the study tree pane, select the node for the equipment item, in this case we'll select LPG Sphere 101, and in the Tools tab of the ribbon bar, click on the pinpoint option. The dot for that equipment item will become highlighted in the GIS input view, and the view will become centered on that dot. Now move to the Input tab of the GIS Input Tools group and check the Labels option. The name of the equipment item will then be displayed underneath the dot as shown. We have now introduced the main types of input data and their organisation, and this section now describes how to work on the detail of the input data. So firstly, we want to open the dialog for the chlorine tank equipment item. So in the Models tab section, expand the Toxic Cases folder and double click on the icon for the pressure vessel equipment item named chlorine tank. The pressure vessel equipment input dialog will open. The dialog contains a large number of input fields organised over nearly 10 tab sections, but you will not normally enter data in every tab section. For an equipment item, the most important inputs are in the Materials tab section as shown, which covers the process materials and operating conditions. Almost all of the fields in the other tab sections are also present in the Scenario dialog, and you would set a value in the equipment dialog if you want the value to be used as a default value for all the scenarios under that equipment item. This tutorial does not attempt to describe every item on input data, but the program is supplied with a comprehensive online help. Every input dialog contains a help button at the bottom right of the dialog. When you click on this button, the online help will appear in a separate window. The help window will be displaying a description of the current tab section, but you can use the links inside the topic and the contents, index and search tabs on the left hand side to reach any topic in the help system and gain a full understanding of the ways that the input data will be used in the calculations and the appropriate values that you should set for the hazardous event that you want to model. Once you've finished exploring the input data, click on Cancel to move away from this window. We will now explore the grid view. The input dialogs allow you to work on the input data for a single item at a time, And the Help button and the organisation of the tab sections means that dialogues are the best way to work on data when you are still becoming familiar with the details of the input data. However, once you are familiar with the data, you may find the grid view useful as a method of working with input data that allows you to view and edit data for more than one item at a time. The grid view appears in a separate tab section in the document view area. To view the data for both pressure vessel equipment items under the toxic case folder, use the following steps. Select the toxic cases folder in the study tree. In the grid view, bring up the list to the left of the filter options button in the toolbar and select pressure vessel from the list. This list is known as the filter list, and it allows you to choose the type of item whose data you want to view in the area below the tool tab. Once you've made the selection from the list, the data for the two pressure vessels under the folder will be displayed in the grid view, with the data fields displaying as a wide list of columns, like in a spreadsheet. If you select the study from the tree, the grid view will display all the pressure vessels in the workspace, and if you change the selection filter list to leak, the grid view will display all of the leak scenarios under the study or folder. This can be very useful for obtaining an overview of the input data and for comparing values between different items. The grid view can also be a convincing way of setting up input data, as you can copy and paste values between cells in the grid view and also between a spreadsheet and the grid view. We will now run the calculations and view the results. In the Models tab section, select the Tank Farm folder. And then click on Run in the Home tab of the ribbon bar to run the calculations. The program will process the calculations for each of the 21 scenarios in turn, performing the calculations for each of the three weathers and showing the progress through the calculations. When the calculation for a given scenario has been completed for all three weathers, a green tick will appear to the top right of the icon for that scenario. This is how the program shows that a scenario has run successfully and has a completed set of results. The calculation will take several minutes to complete depending on the speed of your machine. You do not have to run the calculations for all scenarios and all weathers. If you select a single scenario equipment item, then you can run the calculations just for that scenario or for the scenarios under the equipment item. You can also right click on the weather or on any node in the Models tab section and check the option Exclude from Calculations. When doing this, the weather or set of scenarios will be shown as greyed out in the tree and will not be included when calculations are run. To stop excluding a greyed out node, right click again and select the option Include in all calculations. In the program, a given graphs view can show results for multiple weathers for a single scenario, or for multiple scenarios for a single weather. To compare graphical results for the different LPG Sphere 101 scenarios, you must first move to the Weathers tab section of the study tree, and then select the weather whose results you want to see. For this example, select the category 1.5F weather. This is the weather with the most stable conditions and is likely to give the longest dispersion distances. Once you've selected the weather node, click on Graphs in the Home tab of the ribbon bar. A dialog will appear, prompting you to choose the combination of scenarios whose results you want to view. The folder for which you have not yet run the calculations are included in the dialog, but with a disabled checkbox. Check the box for the LPG Sphere 101. This will select all of the scenarios for this equipment item. When you click on OK, there will be a pause for a few seconds, and then the graph view will open in the document view area. A given scenario or set of scenarios may have many graphs available, and to make them easier to work with, they are organised within groups, where each group covers a different category of results. Each group has its own tab header at the bottom of the graphs view with an icon that identifies the type of result. The graphs include a particular combination of scenarios, which will depend on the type of scenario, on the type of material, and on the details of the dispersion and effect behaviour. The graph that is displayed when the graphs view first opens is the centerline concentration graph in the dispersion group. This graph shows the results at the time at which cloud footprint covers the greatest area. This occurs at a different time for each scenario, as shown by the time entries in the legend. The footprint side view and cross-section graphs in the dispersion group also show results at this time, but the concentration versus time graph shows the concentration as a function of time at a given distance, and the maximum concentration graph shows the maximum distance reached for a given concentration of interest. The graphs in the dispersion group contain results for all 4 scenarios. If you move to the other groups, you will see that most graphs contain results only for selection scenarios. For example, the Jetfire graphs contain results for the 3 leaks only. The Fireball graphs contain results for the rupture only, and the Pool Fire and Pool Vaporization graphs contain results for the 150mm leak only, as this is the only scenario for which this liquid rainout occurs. The graphs view does not display any of the results on the GIS, and to view the results in this form, you must open a GIS results view. The process of opening a GIS results view for the LPG Sphere 101 is almost identical to the process of opening a graph view. Firstly, select Category 1.5 F-Weather, click on GIS on the Home tab section. A dialog will open asking you to select the scenario. Check the box for the LPG Sphere 101 scenario and click OK, which will select all the scenarios for this equipment item. When the view first opens, it will be displaying cloud footprint concentration results, which are present for all 4 scenarios. This is the default form of result for storage scenarios, but the events field in the consequence tab at the ribbon bar gives you the option to pick from the alphabetic list of types of effect for which results are available for the set of scenarios and weathers covered by the GIS results view, and you use this list to select the type of effect to display. The program also presents results in the form of reports. If you wish, you can view a report that covers multiple scenarios, but if you want to compare the report results for different scenarios, it is easier to view separate reports for each scenario and compare between 2. To view the reports for the category rupture scenario for LPG Sphere 101, select the scenario on the Models tab, and then select Reports from the Home menu. You can have many graph views, GIS result views, and report views open at the same time. However, it is best to close a view once you have finished using it, as it will reduce the risk that the program will have problems with low memory. Similar to the graphs view, the report view will normally contain several types of result present in different tab sections. A given tab section will present the results for all the weather conditions that have been processed for that scenario. For the catastrophic rupture scenario for LPG Sphere 101, the first tab section is the input tab section, which lists the input data. All of the other tab sections give details of the consequence results that you saw summarised in the graph window. The summary report summarises the maximum downwind distance to different types of effect and gives a direct comparison between the different weather conditions. If you go to page 7 of this report, you will see that for this scenario, the 5D weather is the one that gives the greatest distance. The discharge report gives details of the discharge modelling and the conditions of the release immediately after expansion to atmospheric pressure. which is the condition used for the start of the dispersion calculation. This report and all the other results reports give the results for each weather in turn. The summary report is the only report which presents a direct comparison between the different weathers. So the dispersion report contains a table which describes the location and status of the cloud at a series of time steps during the dispersion. You might refer to this report if you wanted to understand a particular aspect of the dispersion behaviour in greater depth. The commentary report highlights the main events in the course of the dispersion, and this allows you to see easily if and when different types of behaviour occurred. The centerline concentration given in the dispersion and commentary reports are all calculated using a core averaging time that is set in the dispersion parameters and has a default value of 18.75 seconds. The averaging time report gives the centerline concentration at a series of steps during the dispersion, calculated using alternative averaging times. For the rupture scenario, the only alternative time is the flammable averaging time. In this analysis, this time is also set to 18.75 seconds. So for this scenario, the averaging time report gives the same concentration as the other report. However, if you viewed the report for one of the scenarios in the toxic cases folder, you would see results for the toxic averaging time. The fireball report gives radiation results for a fireball resulting from immediate ignition of the released material. There are other types of scenario in the file that are not storage scenarios. The standalone scenarios each model one specific type of behaviour and will produce a fixed set of graphs and reports. Firstly, the standalone flammable scenario contains pool fire, fireball and jet fire scenarios folders, which perform the same type of radiation modelling as that associated with a storage scenario, but they give you more control over the definition of the flame, and they also allow you to specify in more detail the locations for which you want to calculate the radiation level. The standalone explosion scenario performs the same type of vapour cloud explosion modelling as that associated with the storage scenario, but gives you more control over the definition of the flammable cloud and of the results location. You have now seen the main features of Phast. When you are ready, you should proceed to Chapter 2, which takes you through the stages in setting up your own analysis.